Hi there. Now in this video what I want to do is introduce you to how we handle questions where we're asked to find the locus of a point that moves in a plane. And the best way I can illustrate this is through a typical example. Suppose we've got, say, a point A with coordinates 1, 2 and another point B with coordinates 3, minus 1. And we've got to find the equation of the locus of a point P where the distance AP equals the distance B to P. And what I'd want to do is just draw a sketch first of all, illustrating what we've got here. And here's one that I've drawn up previously. It's not necessarily accurate, but we've got the point A here with coordinates 1, 2 and the point B with coordinates 3, minus 1. So we're looking for where we've got a point P where the distance A to P is the same as B to P. And I can think that one such point could be, say, this point here. Let's just label it P. You should be able to see that that distance there is the same as that distance there. Let's say allowing for just a little bit of error being a sketch. But that's the idea. Now, if I take that point P and just say it has general coordinates x, y, we're looking to find the equation of the point P that satisfies this condition. And when we're concerned with lengths, which you're generally going to find you are, we turn to this formula here. Remember, if you have 2 points, A and B, say, with coordinates x1, y1, x2, y2 respectively, then that distance between them, AB in this case, is, by Pythagoras' theorem, the square root then of the difference between the x coordinates squared plus the difference between the y coordinates squared. So if we start then by just saying let P be the point x, y in general, then we know that since this result is true, we've got the distance AP, which is going to be the square root then of the difference between the x coordinates, that's A and P, all squared, plus the difference between the y coordinates all squared. So we've got x minus 1 all squared, plus the difference between the y coordinates all squared, that's going to be y minus 2 all squared. It doesn't matter, by the way, which way round you write this. You could write 1 minus x all squared and 2 minus y all squared. You'll end up with exactly the same answer. And this is going to be equal to the distance BP. So by a similar method, then this is going to be the square root of the difference between the x coordinates, so that would be x minus 3 all squared, plus the difference between the y coordinates, which will be y minus minus 1 or y plus 1 all squared. Now, because these have got square roots in, I'm going to square both sides. That will get rid of the square roots, and then I'm going to expand all of these brackets. So doing that, what we end up with here for x minus 1 all squared is x squared minus 2x plus 1. And then for y minus 2 all squared, that's going to be plus y squared minus 4y plus 4. And that's going to be equal to, and for x minus 3 all squared, that's x squared minus 6x plus 9. And finally for y plus 1 all squared, that's y squared plus 2y plus 1. And if we simplify this, quite a number of terms get cancelled. The x squareds go, the y squared terms go. And then if I look at just collecting the x terms on the left-hand side, add 6x to both sides, we get 6x minus 2x, that's going to be 4x. And then for the y terms, we're going to end up with minus 4y minus another 2y, so that's going to be minus 6y. And for the constants, we've got 5 on this side, we've got 10 on this side, so 5 minus 10, that's going to give me minus 5, and that will equal 0. I could leave it like that or make y the subject. If I did, y would be equal to 4/6 x, which is the same as 2/3 x, and then minus 5/6. So what we've got here is a straight line. If I was to sketch this on the graph here, remember P is one of the many points on this line, then that line turns out to be something like that. In fact, it is the perpendicular bisector. If I was to just draw that, it's the perpendicular bisector of AB. It's meant to cut through there at right angles, and this length would be the same length as that. And so this line here is essentially the locus of P. So I hope that's given you some idea anyway on how to handle questions like this. Now in the next example, I take this just a bit further. It's a slightly harder question, but I would encourage you to have a go at it as an exercise. Okay,